I'm Doc Searls. This is Floss Weekly. This week, Katherine, Druckman, and I talk with Dave Huseby of Cryptid about authentic data. This is a deep show. This one is all about crypto. It's all about SSI, which you may have heard of. It's about DID, which you may also have heard of. What's wrong with them, though that's not necessarily a problem because it can work with that, but how you can have authentic data across time and space, all kinds of really deep stuff from a guy who's been there and knows an awful lot for somebody who's not that old. So I highly advise checking out this show, and it is coming up next.
Podcasts you love.
From people you trust.
This is TWiT.
This is Floss Weekly, episode 686, recorded Wednesday, June 22nd, 2022, Authentic Data. This episode of Floss Weekly is brought to you by Bitwarden. Get the password manager that offers a robust and cost-effective solution that can drastically increase your chances of staying safe online. Get started with a free trial of a Teams or Enterprise plan, or get started for free across all devices as an individual user at bitwarden.com/twit. And by New Relic. That next 9 p.m. call is just waiting to happen. Get New Relic before it does, and you can get access to the whole New Relic platform and 100 gigabytes of data per month, free forever, no credit card required. Sign up at newrelic.com/floss. And by Compiler, an original podcast from Red Hat discussing tech topics, big, small, and strange. Listen to Compiler on Apple Podcasts or anywhere you listen to podcasts. Hello again, everybody, everywhere. I'm Doc Searls. This is Floss Weekly, and I'm joined this week by Katherine Druckman, who is on screens for those of you not visually impaired, and looking like you haven't moved very far. Because I see you once or twice a week, and you're in one of your rooms in Houston. That's what I know.
It's true.
And yeah,
that is true. I haven't gone anywhere. Probably
and
not going anywhere.
And this is going to be an interesting show because we have Dave Huseby on, and we've had practice with Dave. And just to prep people a little bit, how would you summarize why we have to have Dave back again, and this time on Floss?
Dave always has big ideas, like really big ideas. And, I think it's going to be really fun for this audience to explore them with us. We've done it before elsewhere, but I'm really looking forward to this one because it's going to be a little bit more open source focused and hopefully maybe just more focused all around. But yeah, bringing the big ideas to a bigger audience, I think is going to be great.
Yeah, it is. We've had Dave before on our Reality 2.0 show, which Katherine and I do together.
Ambitious ideas.
Yeah, and Dave is a crypto wizard and a wizard of much else. And I don't want to delay our getting going on that, so I want to let everybody know that this episode of Floss Weekly is brought to you by Bitwarden. Bitwarden is the only open source cross-platform password manager that can be used at home, at work, on the go, and is trusted by millions. With Bitwarden, you can securely store credentials across personal and business worlds. Every Bitwarden account begins with the creation of a personal vault. And Bitwarden has big news. After launching the username generator last month, they're integrating with 3 popular email forwarding services that also happen to be open source. Those are Simple Login, Anon-Addy, and Firefox Relay. So that now adds another layer of security and privacy that's easier than ever. When using Bitwarden to generate a new username, the option to create an email alias is presented with a sub-selection for choosing your preferred service. Just enter the API key for your individual account with the chosen service, select the desired options, and once generated, a new alias is instantly registered to your account. Using unique usernames, email addresses, and passwords for every account is a powerful method for increasing internet security and privacy, and adds protection to logins in the face of data breaches and leaks. This feature will be available on the Web Vault desktop app and browser extensions, with mobile planned for a future release coming soon. So Bitwarden is a must-need for your business. It's fully customizable and adapts to your business needs. Use Bitwarden Send a fully encrypted method to transmit sensitive information, whether text or files, generate unique and secure passwords for every site with enterprise-grade security that's GDPR, CCPA, HIPAA, and SOC 2 compliant. Their end-to-end encrypted vault helps mitigate phishing attacks. Their team's organization option is $3 a month per user. Share private data securely with coworkers across departments or the entire company. Enterprises can use Bitwarden's enterprise organization plan for just $5 a month per user. Individuals can use their basic free account forever for an unlimited number of passwords or upgrade anytime to their premium account for less than $1 a month. Their family organization option gives up to 6 users premium features for only $3.33 a month. At TWiT, we're fans of password managers. Bitwarden is the only open source cross-platform password manager that can be used at home, on the go, or at work, and is trusted by millions of individuals, teams, and organizations worldwide. Get started with a free trial of a Teams or enterprise plan, or get started for free across all devices as an individual user at bitwarden.com/twit. That's bitwarden.com/twit. Okay, I want to welcome our guest here. Is Dave Huseby. Dave and I go back, I don't know, decade or two, something like that. I knew Dave. I think I met Dave when he was at Mozilla. He's been an open source developer since the mid-1990s. I'm looking at his really compressed little bio here. He was platform security at Linden Labs and Second Life, so he has experience with that. He was a senior security manager or engineer at Mozilla. He was the security maven at Hyperledger. I've had Hyperledger people on here a number of times, and an important thing. And now he's CEO of Cryptid Technologies. And I don't know if it's Crypt ID or Cryptid. I assume it's Cryptid.
It's Cryptid.
So Dave, it is Cryptid. It is not encrypted, so I don't know what you said. So I'm looking for your face coming on screen because your face looks better than mine. There he is.
Cryptids, if you look it up, a cryptid is a mythical beast like the Sasquatch or Loch Ness Monster. And we chose to use that name. Yeah, we chose to use that name because we were hunting for things that people have been looking for many, many years, solutions to technical problems, like the last of the hard problems, really. And we think we've done it, and that's what we're going to talk about today. So
and if it works out, you're a beast as well, right? I suppose in a positive sense of that.
It's more like I hope to get lost in the forest, and nobody knows where I am anymore, that kind of thing.
So you go way back with crypto, and we meaning, I mean that in a really large sense. The world talks about crypto, which unfortunately now is sort of synonymous with currency, which is not with a form of currency, and it's much bigger than that. Tell us about how you're coming from that. And we could spin off in any number of directions there.
Oh man, I mean, the real quick answer is I had a copy of Bruce Schneier's Applied Cryptography when it first came out, 1995 or something like that. Just because I was interested in math, I was teaching myself programming at the time, just trying to figure out what this new certificate authority system was that was just being proposed at the time. And I just got lost in the number theory. And I've been involved with like GPG and open source cryptography, Tor projects, all of that stuff since way back when, just either being a practitioner, learning how to apply cryptography to solve problems, or learning how to make secure software, which ultimately led to the trajectory of my career. And when I was working at Linden Lab, Bitcoin, so I was on the Cypherpunks mailing list for a long time. And when Bitcoin was proposed, it was kind of very interesting. I don't think anybody understood it. I liked it because of its cryptography. Mostly that's what attracted me to it. And, I have some friends that are in the Austin Bitcoin group, and I was just down in Austin a couple of weeks ago, and one of them pointed out to me, and I think this is really brilliant, actually. Bitcoin would have never worked if everybody thought it worked. Because if everybody thought it worked, we would have held on to our Bitcoins and we'd have never sold them. And then there would have never been the liquidity or the mass adoption that was needed to get us to where we are today. And it's just absolutely brilliant. And the reason why I'm working today still is because, I was at Second Life in the Linden dollar, and it was like, everybody knows decentralized currencies don't work when Bitcoin was brand new. And so, they all bought because I told them to. Like, these are really interesting. We should buy some, and then I didn't because I thought I was too close to the forest to see, or too close to the trees to see the forest, basically. But so I've been applying cryptography and trying to understand privacy and decentralization for the better part of 20 years. While I was at Hyperledger, we started to see a lot of the cracks showing in SSI, verifiable credentials, DIDs, all this stuff. There's a whole bunch of fundamental assumptions baked into those designs that mostly because the people who designed them weren't on the cypherpunks mailing list back in the late 90s and early 2000s. They weren't part of the Tor project back then, understanding how to build decentralized networks and the incentives around running nodes and all the politics about running a node or that kind of thing. And so I believe they went down a lot of wrong roads. And I teamed up with some really smart people. We've been in sort of stealth mode R&D for the last 3 years. And I started giving hints about what we were working on at the Internet Identity Workshop 2 years ago. I've been giving these talks to standing room only crowds and stuff like that. And I think a lot of our ideas that we're now bringing to market are finally being vindicated, because all of the SSI companies, or a vast majority of them now, are pivoting away from identity and talking about authenticity, which is that's our big deal, right? We talk about authentic data and what that means at global scale, and how identity is really just a narrow special case authenticity. And also that you don't need a cryptocurrency or necessarily a blockchain to do authenticity, because the certificate authority system has been has been issuing and verifying and revoking X509 certificates for 25 years without a blockchain or cryptocurrency. And X509 certificates are authentic data that is cryptographically proven to have come from where it says it came from, that the content hasn't been modified and can be revoked if the content of it is found to be untrue or compromised in some way.
You mentioned the Internet Identity Workshop that we've talked about before, and we know Doc's very involved with too. I wondered, just real quick, kind of how you feel right now about the concept of distributed identity, and maybe do you feel differently today than you did, I don't know, a few years ago, or do you feel differently than the bulk of the community feels?
I absolutely 100% am. I feel completely differently than the bulk of the community does, and I always have. I don't think my feeling about this has changed. I've always been I'm a little bit older than these guys. I'll just be honest. I've always been sort of the gray beard in the back, yelling at the young kids to get off my lawn. Mostly because my background comes from the crypto wars and from the Tor project and from the color revolutions, like real world, for lack of a better term, like actual oppression, people disappearing, people losing their lives, their livelihood, like the seriousness of information warfare as applied to real warfare around the globe. And so I think I've been a little bit closer to the actual physical danger of identity compromise, tracking, surveillance, just general oppression everywhere. When I was at Mozilla, I pushed forward a lot of the thinking around fingerprinting vectors, for instance, right? And the mathematics of the surveillance capitalist system, right? And when I got involved at Hyperledger and was part of this SSI from the beginning, or very, very early on, I was always the guy saying, look, no, progressive, or what do you call it? Progressive revealing of information, selective disclosure, things like that. That does not preserve privacy. And verifiable credentials at this point do not preserve privacy at all. It just slows down the rate at which someone can find out everything about you. And unfortunately, there's nothing that like the Decentralized Identity Foundation is working on that can actually preserve privacy. They like to think they can, but they don't. And the reason is because there's these huge empirical models that have been built from millions and millions of observations of humans in social media systems over the last 15, 20 years. And to the point where predicting or correlating you to your real world identity is absolutely trivial. And it doesn't require as many bits of information as anybody thinks it does. It's actually shockingly low. And it's consistent and it's across all platforms. And so if we want to change the world, we have to understand what we are actually facing.
This is really critical stuff. And I want to point out that I've been around longer than you have.
Yeah, I know. I don't like it when you say you're old, because what does that mean?
I'm an even older. Yeah, but here's an interesting thing. I never, even though in many ways I started IW, and IW I think is actually probably the most leveraged conference on earth right now. I've never liked identity. I've never liked identity as a focus, because identity is, most of the way we get along in the world is without it. When we leave our tribe, whatever our tribe happens to be, we are anonymous in the sense that we are nameless. All the other entity needs to know is that you're human and that you can deal, whatever dealing may consist of. And I agree with you that graduated selective disclosure, once you're either known by an identifier or can be known by correlation and accumulation of data and the rest of it, is not really about privacy in the full sense that the individual is in control of how they interact, right? And it's one of the reasons I never liked decentralized. I never liked something like the person-centric identity, because the centric implies that somebody other than me is in charge of this, and I'm not. And I wasn't I wasn't a crypto guy, but I got what they were doing and I was around it anyway. But I think what you're trying to do here is so different that posing it against what's happening with SSI, which a lot of people, as much as it's taking off in a way, it's not what most of the world knows. But I really like your concept of authentic data. Because in a way that's what you're trafficking in, isn't that what Cryptid is doing? Cryptid is trafficking in a kind of data that's knowable without necessarily being correlatable. Is that a way of putting it?
Well, let me just put it this way. There's actually two layers to this, and I'll talk to that's the bottom layer is where the open source piece comes in and cryptography comes in, and the relationship to the nature of information and how it's bound to time and space and all that. And we'll get to that in a second. That's the big thing of this interview. But in terms of authentic data, that's just what we get when we build systems using the cryptographic abstractions that we're showing the world how to do. And to put it in one sentence, the reason why authentic data is important is it allows us to transmit trust over the internet. It becomes a situation where I can actually own my data because I can become a trusted transmitter of my personal information. Okay, so like if I apply for a loan, I have to give the loan officer consent to go get my credit history. Why? Because they don't trust that I would be a trusted transmitter of that information. Like I have an incentive to modify it, right? I'll get a better deal on a loan or whatever. But if that credit history was instead authentic information, where it was independently verifiable by anybody who had the data, like that it came from where it says it came from and it hasn't been modified. So like it came from, say, a credit rating agency, and it's cryptographically provable to be as it was, as they published it, and that they, as a company, hasn't revoked that information, meaning like my credit history hasn't changed and they haven't pulled back their endorsement of the information. Then I can get that from the credit rating agency and I can hand that to a loan broker and they can independently verify those things are true. So it becomes a situation where they no longer have to trust me. They just have to trust the credit rating agency. Okay, so it's transmitting the trust in that credit rating agency through me to the consumer of the information. Now, here's where this gets really cool. Because of all those cryptographic guarantees of that information, we can now use some of the more modern techniques like verifiable computation to end all sharing of information. So, and what I mean by this is what I was saying earlier, it's shockingly few bits of information that you need to transmit for a recipient of the information to immediately know my real identity and, you know, my search habits and what websites I go to and like everything about me, my political leanings, where I live, my family, all that information. They can decompress a few bits of information, a few observations of me into this complete profile about me, and then target me for whatever, right? You know, surveillance capitalist system. So the best way to prevent that is to not share at all. In fact, it's probably the only way to prevent that. And the way we are doing it is I get my credit rating, history from a credit rating agency. And instead of giving it to the loan broker encodes their policies as a verifiable computation that they give to me. And I run it privately over my authentic data. And what they get back is a single bit answer, yes or no. I do qualify for the loan or I do not qualify for the loan. And the verifiable computation is a way of doing, executing software, if you will, as a cryptographic puzzle, such that I can prove that I did the computation correctly. And I can also prove that the inputs were authentic and unmodified and unrevoked. Therefore, the recipient of that one bit answer of whether I pass or not, or whether I'm qualified or not, can trust that it was all done correctly. And they never saw any of my information. And there are some other slight concessions we need to do because we live in the society, and like here in the American context, we have the Fourth Amendment and all that stuff. So if I were to have a defense against fraud in this case, I have to give them what we call a view token. And by a token, I don't mean a cryptocurrency token. It's just, we think of it as just like a little thing you hold, like a fidget, a view token. It's verifiably encrypted, which means that the recipient can verify that, say, the credit rating agency can decrypt that data, and they hold on to that. So if there's ever any law enforcement or anything that's required, they suspect I was, fraudulent or something like that, then that can be walked back to the credit rating agency, decrypted, and I can be unmasked. So under judicial review in the United States, my privacy is not absolute, but in the happy path where I am not doing anything bad, I do operate, as you said, anonymously. I'm outside my tribe. Nobody else knows who I am. I'm operating with maximum privacy. So that's the kind of power we get with authentic data. But it goes beyond that, like brand protection, authenticity of information, and all that kind of stuff. So like, how do you know that email, to quote the latest Glyph and video, the Global Legal Entity Identity Framework, they're using Carry, which comes out of the Decentralized Identity Foundation. They're pivoting into authenticity as well. And, to quote them, they were like, how do you know that email actually came from the government and it's asking for your personal information? Or how do you know that, that bill from that company is one that you actually owe and should pay? Like, how do you verify that any data that comes to you is actually authentic? Well, what we're offering is a fully decentralized approach to this. Decentralized as in email, decentralized, meaning I don't have to submit to a system to do this. I can do all the stuff client side and assert authenticity of data in a independently verifiable way, using our platform, using our technology, open source, by the way, which we can get to. But I know Katherine's burning with questions.
I am. So, okay. So what you just described, would you still consider this a zero knowledge proof, or is it not, because it does have the ability to be unmasked by, if necessary? How do you define that?
So zero knowledge proofs are just a technique it's a math puzzle that allows you to be convinced that something is true about a piece of data. Now, what we offer, or what we're trying to teach the world how to do, is with authentic data, we actually strengthen the application of zero knowledge proofs to industry in real life, because the inputs and the basis upon which zero knowledge proofs are calculated has this extra layer of, we can also prove that the inputs were authentic and not revoked. And we can actually reveal who verified that information. So for instance, last week, Sam Curran was on here. I'm a big fan. I've known him for years. And he gave that classic example of proving that you're old enough to enter a bar or to buy alcohol, right? Well, he gave what we call the legacy example, which is I actually share some kind of data, right? Like it's a selective disclosure of my age or a predicate proof based on that. Well, they typically use DIDs and they have to anchor in blockchains and all this other stuff. There's all this infrastructure, which I consider silos, right? Because your data is bound to these things that you don't control. And what we're talking about is actually the bar would send you a verifiable computation that you would execute privately, and it would just give a 1-bit yes or no. And I don't have to share anything. And I also have the ability to say, well, this data was, say, verified by the DMV of the state of California, right? So I can actually prove that it's authentic, that it wasn't revoked, that it was the input to the zero knowledge proof, in the form of the verifiable computation. And so it gives this extra layer of, authenticity, right?
So I wanted, I don't know if we've completely plumbed that topic, but I love that you're giving us a different hack on a different angle on zero knowledge proof. In fact, you started that with one of the best explanations of what zero knowledge proof is in the first place. But I want to take this to open source because that's our middle name, most of our name. And you've got a lot to say about that. But before I do, I have to let everybody know that this episode of FLOSS Weekly is brought to you by New Relic. If you're a software engineer, you've been there, it's 9 p.m., you're finally unwinding from work, your phone buzzes with an alert, something's broken, and your mind's already racing at what could be wrong. Is it the back end or the front end? Is it global? Is it the server? Is it the network? Is it the cloud provider? Do we have slow running queries? Did I introduce a bug in the last deploy? Now the whole team is scrambling from tool to tool and messaging person to person and working at finding the issue. According to a New Relic report, only half of all organizations are implementing observability for their networks and systems. The report showed how maintaining network observability continues to be an issue for companies around the world. That won't happen when you get New Relic. New Relic combines 16 different monitoring products that you'd normally buy separately so engineering teams can see across their entire software stack in one place. You get application monitoring, that's APM, unified monitoring for your apps and microservices, Kubernetes and Pixie, instant Kubernetes observability with Pixie, distributed tracing, see all your traces without management headaches so you can find and fix issues fast. Network performance monitoring, stop guessing where performance issues start and ditch data silos for a system-wide correlated view, and so much more. More importantly, you can pinpoint issues down to the line of code so you know exactly why the problem happened and can resolve it quickly. That's why the dev and ops teams at DoorDash, GitHub, Epic Games, and more than 14,000 other companies use New Relic to debug and improve their software. Whether you run a cloud-native startup or a Fortune 500 company, it takes just 5 minutes to set up New Relic in your environment. So that next 9 p.m. call is just waiting to happen. Get New Relic before it does, and you can get access to the whole New Relic platform and 100 gigabytes of data free per month forever. No credit card required. Sign up at newrelic.com/floss. That's NEWRELIC.com/floss. newrelic.com/floss. Okay, so Dave, you've got an open source story here. And it's not just that, it's open formats, open protocols. Tie that to sovereignty, tie it to, take it any way you want. I mean, you've got a company, which means you're selling something with Cryptid,
One
but
hopes.
you're also in the open source world. You've been there for a long time. To tie those
Yeah,
up
I mean, the company sells enterprise solutions to automate the use of these open technologies to make money, obviously. I mean, we take a business approach that's very similar to GitLab, right? GitLab is built on top of Git for software development. And, they don't even control Git. They contribute to Git, but they have a whole enterprise package built on top of Git that allows companies to, automate internal teams to develop software. So we have the same business approach. We have all this stuff for managing authentic data and stuff, because authentic data is essentially NFTs without cryptocurrencies. And you can do private art sales, you can do public art sales, you can do all this stuff, right? It's the mother of all digital rights management systems, if you really think about it. And so there's use cases in basically every vertical, every kind of industry, right? This is deep thinking that changes a lot of how the internet has been done and how business is done. But to get back to open source, which is kind of where my heart's always been, right? I think the very first piece of software I ever wrote and made available was GPL licensed back when, like 1994. So I have a new blog post coming out, like a couple of days. It's currently being edited. I tried to get it out before the show, but I've been trying to come up with sort of like this grand unified theory, because I like to try to figure out how everything's tied together. And we've been really thinking hard about what authenticity and information, the true nature of information is. And I think that the coolest thing about open source and open formats, open protocols, is that it is our best way we know to unbind information from place. So as soon as you start getting computers talking to each other over a network, you have to decide, what does the information, what are the bytes between our computers mean? What should the recipient computer do with the bytes that the sending computer sends? Okay. And I think our best solution, and the proof of this is that the entire internet runs on open source and open protocols. I think it's pretty fair to say that now. There aren't any really widespread proprietary protocols anymore that are in common use for everyday people. Almost everything, literally everything, is HTTP, is RSS, is we run open source libraries for all of that. Linux kernel finally won. I mean, it's literally in everything except maybe desktop computers. And so what we got when we started pushing this, back in the 90s, it was really ugly. It was always like, nobody's ever going to use open source because there's no neck to choke, right? Like, who are you going to sue if it goes sideways? And it wasn't about that. And I think we finally got to the point where we understand it. And it's only been in the last 10 years that open source software provides a standard-ish, like a way we all agree to process data of certain types. You receive an email, it goes through some open source. You receive packets from a web server, it goes through open source. You send a tweet through an app, it goes through open source end to end. And so the software sort of normalizes how we all process data across the entire internet. Protocols normalize how the computers themselves talk to each other. And then open formats normalizes how we store things. And so it unbinds information from place. Like, I can encode some information in an open standard file format, then transmit it using an open protocol, and the person on the other end or the system on the other end will have open source software that will know how to process it. So we can freely move information globally because of open source, right? So that is sort of the beginning of this. And then the other side of this, one of the things I realized, about 10 years ago, I think, is Signal that old? The Signal protocol? I'm not sure if it's that old, but when the Signal protocol came around, and I guess a little bit about Bitcoin too, I realized that the coolest thing you can do with cryptography is you can unbind data from time. So I worked as a contractor. I'm going to just give you an anecdote here. I worked as a contractor for Boeing on the 787 test program once. And I was working in part of the archive process of this, right? They fly test aircraft, they collect tons and tons of data, hundreds of gigabytes of data each test flight. They have to put it in some archive so that the engineers could later go and analyze it. Did they pass the test? What is the airflow over the wing really look like when it's actually flying? All these things, right? It all rests on the archive. One of the problems that the deep thinkers at Boeing were actually tackling at the time, and this was like 2006, 2007, was how do we preserve this information for 100 years? Seriously, like how do you transmit this information? First of all, it's too big to transmit in space, right? It goes back to the old joke, right? Never underestimate the bandwidth of a station wagon full of tapes. So they had so much information and like petabytes and petabytes of information that they couldn't easily transmit it from their archives in one place to another. So they had to make sure that the data was networked. So they used open software, open protocols, open formats. Then they were trying to figure out how do you transmit this stuff through time? And their main concern was bit rot, or what we call bit rot, and that's typically because hard drives fail, disks fail, floppy disks fail, tapes fail, like all of our storage medium degrades over time. And the techniques that they were applying were cryptographic in nature. We've known for a long time error correction, ECC coding, stuff like that. But the encryption piece allows you to bind controllership. Like I am the person authorized to deem this data set official Boeing data. Okay, so I have an identity inside of the company. I have a role inside of the company, and I can bind that or my approval or my role in the company to a data set using cryptography. And we can apply error correction to it and all these techniques that give us authentic data, right? They're essentially trying to make us data set that's authentic, that in the future, given bit rot, they can actually correct the errors, verify that it is authentic, because they can go back in history and be like, oh yeah, that person was the official person who was doing this. So this is actually authentic at some arbitrary time in the future. So if you combine those two thoughts, open source, open protocols, open formats, with clever cryptography, it is possible to create what I call unbound authentic data. This is data that is unbound to time and space. And we have some protocols. I just implemented a version of Disco. If you look it up, Disco Crypto, it uses a message format that is open, and it uses a cryptographic construct called the strobe script. And I'll get to that in a second. That's a critical cryptographic thing that's used in zero-knowledge proofs. But what it allows us to do is create messages that are unbound in time and space. I'm convinced that this is how we would send secure messages between planets or between star systems even, because they're error correcting and they're verifiable and authentic and all the things. So the reason this is important is because once you get there, you realize that all you have to do is figure out how to bind unbound data to a specific point in time. And now we have everything we need to make a fully decentralized, authentic data, like a fully decentralized e-commerce internet that operates entirely in authentic data and doesn't require any silos. More importantly, it can use anything, actually. So like, if you and I start a Disco session, Doc, or let's say I create a provenance log, I create my own digital identity as a piece of authentic data, and I send you a photograph I took as authentic data. It doesn't matter how you get it. I can send it to you over HTTP, I can email it to you, I can print it out, as long as there was a way to redigitize it, so there's like a QR code version of it or whatever. And you could verify that it's authentic and that I bound my identity to it as the creator of this photograph. And that's true for over all space and all time. So I was saying earlier, like my nitpick with the DID stuff, the decentralized identity company, decentralized identity organization and DIDCOM and DIDS and all this other stuff is that they think they need to invent something new. And I think they think that because they didn't really understand the problem. And once you really understand the problem and the tools that we use, open source, open standards, open protocols, and some clever cryptography like strobe and cryptographic accumulators, you can now free data from time and space. And then all we need is a way to establish a total global ordering of events, right? What happened before, what happened before, this is getting very esoteric and like information theory and how do you know what happened before, what happened after, like what came first and what came second, right? It turns out all you really need is a global clock that everybody agrees on. And our technology, like I said, is not bound to any specific thing, but I think that one of the key values of Bitcoin itself is that it is a clock. It's a global clock that everybody agrees on. It ticks roughly every 10 minutes. And we can bind data to these ticks, which says that, if you use the right cryptography, you can say this data existed in this state at this time. So for me to assert my intellectual property rights of a photograph, I would take a photograph, create a provenance log, which is essentially an off-chain key history that contains also the information, the metadata about the photo. And then I can use like a cryptographic accumulator to compress its state and the state of an infinite number of other pieces of data actually into a single like 80 byte proof that can be put into a Bitcoin transaction. So all of those external pieces of data with their own provenance, in a certain state gets put into this accumulator and put into a single transaction. And all that's doing is taking unbound data that's unbound in time and space because it's open protocol, open format. And we have a state proof based on cryptography, and putting it to a specific time, binding it to a specific point in time to assert the necessary place in the order of events so that all of the rest of our society can function, right? Like, and what I mean by that, here's the most poignant example, I think. Why do we say that Edison invented the light bulb? Well, I think we all know that there was like 12 other inventors working on the light bulb at the same time, right? And they all came up with various takes on the incandescent light bulb pretty much all at the same time. But Edison was the one who filed the patent first. So Edison is actually the official inventor, even though he may not have been the spiritual inventor of the light bulb. Does that make sense? So when you want to bind this kind of like unbound data so that we can get real work done, so that we can have businesses, so that we can have money and we can have, an accounting of events and who signed what and who bought what and did it get shipped and all that other stuff, you really only have to have like a way to say that this happened, then this happened, then this happened. And so the open source is actually a critical piece here because you have to unbind information from place, and then the cryptography unbinds it from space. And then all you really need is Bitcoin and key history, and you can reinvent the entire internet with authentic data. How's that for a big thing?
My mind is blown as usual. This is why I love talking to you, Dave, because you make me want to be smarter. It's so great. Anyway, so I do have a question though. So you're talking about unbinding data from time and space, which is fascinating and slightly mind-blowing and all of those things. But at some point, data has to be bound to some sort of storage medium or a transmission protocol or something like that. And how do you envision, how does that work? So you've unbound it, you've then tagged it with a verifiable blockchain-based timestamp, but still it has to live somewhere. And how does that fit into your vision? Oh,
so okay, obviously it has to be open source, open format.
And how does it last for the next? How do I find it in 100 years? That's the real question. How do I find this data in 100 years? Where is it?
So that I think is where you have to get into application specific, right? And this is kind of what the Long Now project is all about. How do we preserve the entirety of human knowledge and experience over long distances of time, right? And that is definitely an active area of research. There are people, like I know a bunch of Bitcoiners who put their hierarchical wallet seeds, etched on a piece of stainless steel, right? And they do it in such a way that there's like 5 of them, and you only need to have 3 of 5 to recreate all of the keys so that they can eventually, essentially pass on their Bitcoins to their children or something, right? The physical medium itself is an interesting question, but I don't think that I have much to say on that other than use something that's durable. I mean, but what we do know is that we can use self-describing open formats and cryptography to make sure that when it is found, you can tell where it came from and you can, correct for the errors and things like that. So there's a bunch of other lessons that we've learned through our R&D over the last 3 years that I'm just going to give this out. And at the risk of catching up some of our competitors, I think we're probably a couple of years ahead of them, but, consider this open source goodwill, right? Some of the most common mistakes you see today in all of these new decentralized systems is that they use naked key pairs. Don't do that. A lot of systems will use public keys as an identifier, which are stable across systems, time, and space. And so you can correlate activity. I mean, that's the mother of all tracking, right? Don't do that. But then even people, I think, who should know better still fall into this trap because they can't think, they're at least not thinking in terms of time, right? If we're now going to have data that's digitally signed, then there's going to be old data that is digitally signed with old keys. And so you need to have some kind of key history. So I think the basic sort of indivisible unit of identity or indivisible unit of control has to be some form of key history. Because if I have old data that I signed with an old key pair and I've rotated my keys and I want to do business with that old data, then I need to be able to show that the public key that you use to verify that signature is somehow cryptographically bound to my current key, which I can use to prove that I control it. So, Sam last week was talking about how that you can use control of a key pair to do some interesting identity-based interactions. Well, what if we're talking about old data? Well, you have to have those old keys bound to my current state. And the only way to do that would be to make your basic unit of meanness, or the basic unit of I control, I have a presence, I am a first part. What did Sam say last week? I'm a first class citizen as a human on the internet, right? You have to have a basic unit of information that gives me the ability to assert that in any system. And I would argue that it has to be a key history, not a key pair. And the DID documents sort of do this, but not really. They're not. First of all, they do contemplate time, and they do provide sort of an accumulation of history, but they don't use something like a strobe transcript, which actually encodes state over time. And I don't want to get too technical here, but strobe transcripts are how we make interactive zero knowledge proofs into non-interactive zero knowledge proofs by unbinding the interactiveness. So it unbinds the truth from time. And again, this is why unbinding information is so important, because it allows you to think in ways that would make you look at a DID document and go, yeah, no, that's not how you do it. The way you do it is a strobe script that records your key history and has cryptographic puzzles between them so that you can prove or delegate authorities, and you can ensure that you're the only one to update it. And you can also ensure sort of continuity of custody of that over time. Plus it allows you to say, okay, yeah, that old data that was signed with my old keys, I can prove to you that was me back then. So if I can prove to you, if you trust me now, you can trust that data from back then. So that's one of them. And I'll just sum it up, right? The most, the tiniest indivisible unit of meanness on the internet has to be a key history, not a key pair. So don't do naked key pairs.
Wow.
And I have a few others, but I'm sure I don't want to give away all the sauce.
Yeah, and again, we only have an hour, and but I want to go, because these are familiar things, to something you said, and I'm teasing you with this because I'm going to go to an ad, which is, why do I think the web is never decentralized, and why do you think that Web 3 is being talked about now, and now Jack Dorsey with his block company, but is doing it in a DID SSI kind of way, which you've already crapped on. And I think I'm in an interesting case. So I want to hear more about that. But first, I have to let people know that this episode of FLOSS Weekly is brought to you by Compiler, an original podcast from Red Hat discussing tech topics, big, small, and strange. Compiler comes to you from the makers of Command Line Heroes, which is another one of our sponsors. It's hosted by Angela Andrews and Brent Simoneau. Technology can be big, bold, bizarre, and complicated. Compiler unravels industry topics, trends, and the things you've always wanted to know about tech through interviews with the people who know it best. On their show, you'll hear a chorus of perspectives from the diverse communities behind the code. Compiler brings together a curious team of red hatters to tackle big questions in tech, like what's technical debt? What are tech hiring managers actually looking for? And you have to know how to code in order to get started in open source. Episode 2 covers what can video games teach us about edge computing. The internet is a patchwork of international agreements and varying infrastructure, but there's something coming to change the ways we connect. In this episode of Compiler hosts explore what edge computing could mean for people who enjoy video games and what this form of entertainment could teach us about the tech. Episode 9, how are tech hubs changing? Traditionally, if someone wanted a career in tech, they had to make a move to a tech hub, a city packed with startups and talent, but things are starting to change. The hosts of Compiler speak to a few of the change makers who are thinking outside of the physical and social dimensions we've come to associate with innovation. And I have to say, this one's close to home for me because Red Hat itself is in the Triangle area of North Carolina, which is a tech hub now, wanted to be a tech hub back when I lived there from the 60s through the mid 80s. And I ended up moving to Silicon Valley because it was a real tech hub. And then I moved away from Silicon Valley because I didn't need to be in one. And so that's really at the center of the point of that episode. It's worth listening to. Learn more about Compiler at red.ht/twit. New episodes are out now. Go and download them at any time and be sure to check back for new shows. Listen to Compiler on Apple Podcasts or anywhere you listen to podcasts. We'll also include a link on this episode's show page. My thanks to Compiler for their support. So Dave, like I teased a moment ago, there right now yakking about Web 3. We have Web 1, we have Web 2. There never was a Web 1, Web 2 named Web 1, and later Web 2 got named. These are sort of simplified ways of thinking of eras. And it seems to me you're thinking way beyond any of this. And I really like how you've kind of decoupled what you're trying to do from both time and space and the way you're doing it. But there's a lot of energy going into that. And now Jack Dorsey with Block, which used to be square, but then it got three-dimensional. He's come out with Web 5. And the interesting thing to me about that, and I was just looking at the slides earlier, I'm going to have to bring them up and we'll put them in the show notes, is that it's right from the songbook that, I and my cabal and my developers that I've been mostly talking to, and in the SSI community, which used to be nothing and is now something, and the diff with DIDS. If he succeeds, he's going in a direction. Now you're saying that's a big mistake, but I'm wondering if you can make. So I mean, if somebody doesn't want to do that, what do? Okay, if they buy your argument, hey, wait a minute, DIDS is the wrong approach. Forget web numeral. We're going past all of that. What do you say to that? That can kind of pry people off of that and start looking at what you're trying to do and say, yeah, it's better. We'll do that.
Okay. So you tease that I believe that the web was never decentralized. I can back that up with a ton of facts.
Oh yeah, I agree, but go ahead, back it up because I think it matters.
I mean, for many people in the early internet, AOL was it, and that was a garden. It was a walled garden. It wasn't actually the broader internet, and the web specifically. The first commercial use, or like the first, I guess I might get this wrong. This specific fact, I don't remember the exact company. Was it Lycos or somebody invented the idea of let's make a search engine and then we'll gather intelligence about the market from the search terms, and then we'll target advertisements to our users of our search engine. I think it was Lycos. Correct me if I'm wrong. It might be a different company, but what I do know is true is that existed in 1994.
Anyway.
So the web itself was barely 3 years old, and that business model already existed. So think back when you first got a web browser and used the web. I think most people, it was probably 95, 96, 97, maybe as late as 2001 or so. By that point, surveillance capitalism was already the dominant business model on the internet and had been for years. By the time you first used the web, it was already there. So the web itself was not ever decentralized. I mean, they say, oh, it has a decentralized architecture. Sure, anybody can run a web server or whatever. But this gets to my bigger point, and why I dismiss sort of the Web 3 and the Web 5 stuff is that people throw around the term decentralized a lot, and I think they are using it in a confusing manner. Decentralization is about power to me, not about computers. Distributed is about computers. I mean, Facebook uses tens of thousands of computers. That's a distributed system, but nobody would argue that Facebook is decentralized, right? You don't have any kind of sovereignty over your data. It's basically you submit to their rules to use Facebook or not, right? And decentralization about power is pushing power to the edges. It allows individual people to define the role and the degree to which they interact with any system. So how much data they share, whether the system is able to store the data, can I force the data to be deleted, all that kind of stuff. And we're seeing a reassertion of this through government privacy regulations, right? Right to delete, right to be forgotten, that kind of stuff. So I don't like their use of decentralization because they are building systems that bind my personal data to their systems. I mean, the Web 5 stuff uses ION, which is side tree, which is like an accumulation of Merkle trees, Merkle roots, and all this stuff, and gets anchored to Bitcoin. And that all sounds cool and everything, but they're also trying to solve higher level problems like discovery, search and stuff like that. And so that means that they have to store a certain amount of data on you. And so now we're also submitting to a system. Okay. And they claim to be decentralized, much like the Carry people, building Glyph, say that their system's a protocol and it's decentralized. Well, it's distributed, but does it really push the power out to the edges, out to the individual users of the system? And I would argue no. And the reason you need, or the way to achieve full decentralization is to design a system where there is actually an incentive model for people to run nodes or to support the global system as I say, an honest node operator, right? I'm going to be one of the nodes in the distributed system, and I'm going to be an honest node and protect all the people who connect to me. You have to have an incentive to do that. And the most common way to do that is money, frankly. And I would argue that the internet itself was not decentralized in the sense that it was quickly commoditized or quickly centralized on commercial platforms. I mean, like GeoCities, Yahoo, and AOL, and from the very beginning, our experience on the web was almost entirely mediated by corporate interests who were making money off of us. So that alone doesn't really decentralize anything. That's just distributed. And what we get with something like Bitcoin, and I think probably one of the coolest sort of revolutions that it represents, is it for the first time gave financial interest to people to run nodes. And now we're seeing with the Lightning Network, we're getting the same kind of thing. And I don't know, I just, what we are doing is not really making comment on, or we're not trying to build a new network, right? Because we don't have a way to provide a financial interest for people to run nodes. I think it would be really cool if someone bound a Bitcoin node, a Lightning node with Nostr and an authentic data anchoring system to replace, basically a payments processor like Venmo or something with a pub sub, microblogging platform like Twitter. Nostr replaces Twitter effectively, and then the anchoring service allows anybody to deal in authentic data. So you could do like a fully authentic replacement of payments and basic, Twitter-like behavior with a financial incentive. Like, great, I want to see that project. I'm not going to do that. What we're doing is trying to commoditize the internet as a whole. Once you get these tools, these open source tools that unbind data from time and space, now you no longer have to have things like DIDs. You can use URLs. You don't need to have something like trusted storage, that's bound to a blockchain like Filecoin or anything like that, because you can use S3 buckets. Authentic data can be transmitted through time and space in any form over any medium, over any amount of time. So I can put it into a file that's a standard file format and put it in an S3 bucket. I could shoot it to you, Katherine, as a QR code printed on a piece of paper, attached to the leg of a carrier pigeon. It doesn't matter how you get it. You can immediately verify that it came from me and that I still stand behind it and that it hasn't been modified. So what we're seeking to do, and the reason why someone would want to go with us, is because you don't have to change your existing systems. We're just adding integrity and verifiability and authenticity to everything your corporation or company does. And you no longer have to submit to external services. So like you wouldn't have to rely on Block and Web5 to be able to assert that the data your company creates is authentic and that it was an official communication from the board or an official, advertisement or an official contract from your company. Okay, you don't need to submit to them. You can create it as authentic data, and to provide the independent verifiability, you just anchor it in Bitcoin using our anchoring service. But the anchoring service is open source, and it accumulates state changes. Well, it's essentially, to put it in blockchain speak, it's an infinitely scalable layer 2 solution, because you can include state proofs from all, an infinite number of authentic pieces of data into a single Bitcoin transaction. So it's not bound to Bitcoin. We can use any blockchain, anywhere that any system that represents a clock that everybody agrees on and stores small amounts of data that is effectively impossible to edit in the future. And anybody who is interested can read that information. That's really all you need to anchor. And I guess my main argument here is that if you like the email you have, you can keep the email you have. We can just put a provenance log attached to it, and now everybody can verify that it's authentic. And same for software development and everything else, right? So,
yeah. So we're pretty much out of time here, but I want to ask.
Sorry about that. One
question. Well, no, you've done a really good job of covering a lot of ground here, but you've mentioned Kerry several times. My guess is that 99.x% of our audience does not know what Kerry is KERI for Key Event Receipt Infrastructure. What I want to ask you about this is that I recall like 2 or 3 IIWs ago, you and Sam Smith, who invented Kerry, or was a primary inventor of Kerry, had an argument, and then you kind of worked it out. And what I'm wondering is, and you're saying you can keep the systems you've got. What if somebody's already using Kerry? Is there a Venn here where Cryptid and Kerry are both in play, or not just Kerry, but other things like that? Or is this a knife edge difference that it's one or the other?
No, because
kind of wrap with that.
Right. So Kerry's primary use case right now is GLIFE, Global Legal Entity Identity Framework. Okay, they're going to give a digital ID to every corporation, government entity, whatever, right? So think of it as like digital driver's licenses for companies, right? Much like the certificate authority system, they will go and verify that you are the company you say you are and back your identity. So I would argue that they function as one of those societal institutions that we are all trusting. Like what I was saying earlier, like you don't have to trust me. You just have to trust the credit rating agency, right? I can transmit their data through me to you, right? You wouldn't have to trust me asserting that I am Cryptid Technologies or, the CEO of Cryptid Technologies. You just have to trust GLIFE that they did their homework and verified our identity. So we are completely agnostic about where the verification comes from. It can come from a government, it can come from a church, it can come from a civil rights organization, it can come from GLIFE, it can come from the certificate authority system. You can mix that information into a provenance log in which you maintain your meanness, or like the provenance log for Cryptid Technologies, right? I can mix in the GLIFE information. I can mix in the certificate authority information using cryptography. And then I become a trusted transmitter of it, and I don't have to rely on the Kerry network, actually. I don't have to rely on their protocol or anything like that. So you can think of us as sort of a superset. Like we're sort of the trunks and the last mile for transmitting the trust from any institution. I think that's the short way of putting it.
Okay, so we're now almost more than out of time. So I just normally have some two final questions which we ask everybody, which are, and answer them briefly if you can, which are, what's your favorite text editor and scripting language?
I'm not a communist, so it's not Emacs, and I'm not a fascist, so it's not VS Code. I've always used Vim. I cut my teeth on Unix systems at University of Washington. I'm a Vim coder. And then for scripting language, I'd have to say Rust.
Okay, great.
Of course. Hey, it runs. It compiles to WASM. It runs in a browser. Don't tell me it's not a scripting language.
Okay, that's fantastic. Well, Dave, this has been an action-packed hour, and things are going to change and improve. And I hope to see you at the next IW event area. So go to the next site. If you want to talk to Dave, that's a great place to do it. Really great having you on the show, man. As always.
Thank you, Doc. It's always great. And thank you, Katherine.
Yeah, always.
This is the first time I've talked to you. I'm starting to think of uses that I have. so that's interesting. It always
happens eventually.
Yeah. Thanks a lot, Dave.
Thank you.
So, Katherine, as briefly as we can.
That was great. I know, that was great. Yeah. Dave has opinions. I love it. A lot of opinions.
Yeah. I've been writing down in our back channel all these one-liners and two-liners that are really good. And I was going to look at the back channel for some questions. What I see is Dave is active in their back channel too, because there's nothing closed about their back channel.
I'm so envious of Dave's energy.
Yeah, it leaks over everywhere. This has been great. So I guess we just get to the plugs.
I know, yeah. What do I have to plug? You get some Drupal in your life. Plug how, you know what? I rarely say this. I work with some amazing people and I feel like they deserve a plug. All my Acquia colleagues, soon to be former colleagues. Well, I guess that's out of the bag. Anyway, they're fantastic people and I'm so lucky that I have gotten to work with them for the last several years. And use some Drupal and go meet an Acquian and thank them for being awesome.
And go back. We had Dries, the originator of both Drupal and Acquia, on the show. Yeah. So that was
brilliant guy.
That was great. So hats off to them. They're great. And hats off to you. And thank you, everybody. This has been a great show. Next week we have a roundtable, which is going to be rectangular for those of you who are watching on a screen. But it's going to be, a number of us will be back to talk about the news and stuff that's going on. And that's coming up next week. We'll see you then.
Don't miss All About Android every week. We talk about the latest news, hardware, apps, and now all the developer-y goodness happening in the Android ecosystem. I'm Jason Howell, also joined by Ron Richards, Florence Ion, and our newest co-host on the panel, Wen Tu Dao, who brings her developer chops. Really great stuff. We also invite people from all over the Android ecosystem to talk about this mobile platform we love so much. Join us every Tuesday, All About Android on twit.tv.